Okay, hi guys. So once we reach the end of page 4, well, up to this classroom activity over here, that is what you're going to be tested on, up to what you're going to be tested on for your summative assessment. Okay, so we're going to start with seeing light. Now, there's a lot of misconceptions in the way people think they see things. Okay, so you are seeing this, or you are seeing things in real life like this. So in order to see light, oh gosh, that's a very bad punctuation. I apologize. In order to see, comma, light must reflect off of surfaces into the eyes. Now, I'm going to draw, this is an eyeball. It's the side of an eyeball. Okay, there's some eyelashes. Now, a lot of people, what they do is, let's say this is just a block over here, sorry, is that they like to draw that the light, that the, oh, no, sorry. No, let me try that again. This is an eyeball. Very often scientists draw eyes like this. Okay, and here's it's a side view of an eyeball. Okay, there's some stuff. Okay, now what a lot of people tend to do is they tend to draw a light ray going to this box, for example. And that is wrong. You can't, how can you imagine yourself? You're not Cyclops from X-Men. You can't beam light rays out of your eyes. Okay, so something else must happen here, that your eyes are capturing light. Remember, you got that big pupil in the middle of your eyeball. Okay, there's your iris, and you've got that black hole in your eye that opens and closes, well, not closes, but it gets bigger and smaller depending on how much light. It lets light in. Okay, so please remember that. So we get light, okay, from the sun, from a light bulb, from a candle, and that light shines and radiates out, and it hits everything around us. Okay, it lands on everything. So this man very thoughtfully is looking at a flower. Okay, and the light from the sun hits the flower and it bounces off the flower, and the light that goes into the man's eye allows him to see the flower. Now, obviously, we're getting light coming off of lots of things that are going into our eyes all the time. That's why we can see so much at one go. But this is just taking one little light ray from the sun and one little light ray that comes off of the plant, and we can now see, oh, look at that, he sees a flower. Okay, so the light must come from a light source, and it bounces off. There's a special word for this. Do you know what it is? It bounces off. It reflects. It reflects off of the flower and into the man's eyes, and then his brain interprets it. Okay, so complete the diagram below to show how you see Miss Harry. Now, obviously, this would normally be with me in the front of you. So we are going to, I'm going to flatter myself by drawing a stick man. Okay. Let's give me some hair. I don't mind a bit of curls. All right. So there I am there. Now, you would be looking at me sitting at your white lab desks, and I'd be at the board, and you see me. Okay. So if you're far away enough, you can see all of me. Now, what happens is light will bounce off me in all different directions, but I'm only going to draw a few. So, oh gosh, I really should use a ruler for this. This is not really a ruler, but I don't have my ruler here. Okay, so let me try that again. So it will bounce off over here. Okay, I wonder if I should have done it. Oh, that's fine. Okay, and we only put one little line, one arrow to show it's going in there. So, you know, the fluorescent lights that I have in my lab, and will come from my feet and everywhere in between as well. Okay, so you'll have all the light coming off of me and going into your eye. We're just showing two light rays. Okay, now what's happened is that my feet have landed up here, and my head has landed up here. So what has happened, I have landed upside down on the back of your eyeball. Okay, this is called your retina. Retina. I think that's how you spell it. Okay, what, you can look it up. Okay, it's on the back of your retina. Now it's like a screen. It's like having a movie screen shone, and you can see it. If you could try and see inside an eye, you could possibly see yourself at the back there. It would be like a proper screen because you've got this magnifying glass. Oh, I wish I had my magnifying glass. Yeah, I could show you some things as well. Okay, so what happens is that there's these nerves that go to your brain from your eyeball, okay? And your brain interprets it and puts me back upright. So, oops, and slightly changed. So I'm now upright again, and you can now see me. But how quick does that happen that you don't ever see me upside down? All right, so that would be your final image. So you start upright, your eyeball turns it upside down because of the lens over here. It turns me upside down. Your brain interprets it, and final image that you see is that. Okay, right, we're going to talk colors now. So how do we see color? So we're going to complete the diagrams, and we're going to see now, how do we get this? Now, here we have a black cat. Now, just looking at this black cat as it is now, we see it as black. Now, very often there's a debate going whether black is a color. And I'm going to show you why they think that. Okay, here's an eyeball, like I said. All right, so here we're going to see light from the sun. Now, the sun produces white light, okay? And we know that because when we pass it through a prism, it breaks up into the spectrum of light, which is the rainbow colors. So here we have our sun, and it will hit the black cat. But what's going to happen here? None of the light shines into our eyes. There is no reflection. Okay? The black cat has absorbed all the light. Even now, as we look at this picture, and you can see it as black, it's not reflecting light for that. I got my light bulb on here. It's not reflecting that light. It's actually absorbing it. And that's why things that are darker colors will get hotter, because all the light's absorbed. So the black cat absorbs all the light. There's no reflection, and we see it as a black cat. All right. Now, if we were to see a white cloud, so a white puffy cloud, so we know that we get the white light here. Okay. To see the white puffy cloud, what's going to be reflected? So that we can see it as white, all the light is reflected. All the light is reflected, and that's why we can see white. So as we're looking at it right now, I can see this white color, and that means all the light is shining off of it from my light bulb. Okay, and we see it as the color white. Now, that's why some people argue that black isn't a color, because nothing's reflecting. So it's just an absence of light. All the light is being absorbed, and you don't get any light coming into your eyes. So that's the debate. Okay, you can make up your own mind. All right, so let's take a look at now, how do we see? So here's our eyeball over here, and I'm going to look at these different colors. So you're going to take your colors, and let's make this orange. I don't know if I have all these colors, but we're going to try. So we have an orange, okay, and what happens now is white light from the sun hits the orange. Okay, we know that white light is made up of the colors of the rainbow. We know that each one of them is Roy, G, Biv. Red, orange, yellow, green, blue, indigo, violet. We know that each one of them have that. Okay, but what happens here is we see only the orange part. So again, I don't have a ruler. Maybe I must, excuse me. So here's my girl's eye. So I'm lining it up with the orange. And she is now seeing it as orange. Okay, and it's going into her eye. So we put a line. So she sees it as orange. What is happening to the red, yellow, green, blue, indigo, and violet? That is being absorbed. Okay, so here we know that the red, not orange, yellow, green, blue, indigo, and violet is absorbed. I'm going to put your absorbed here so that we can just write that under each one of these. Okay, the banana we'll write somewhere else. Okay, so everything that is absorbed, all the colors of the rainbow except yellow. Orange, sorry. Orange is the only color that bounces off the orange and into the eye. Now, obviously, you get combinations of these to give you all the different types of colors. You can have a little bit of red with a little bit of green maybe being bounced off, and you'll see a different shade. Okay, so we don't just get those 7 colors, we get millions of other combinations. Okay, so again, here we have our green broccoli. White light is hitting the green broccoli. Okay, so we have a green broccoli. Okay, and the reason why we see it as green is because the white light is hitting the green broccoli, but only the green light is reflected off of it. So what colors are absorbed? It would be the red, orange, yellow, B, R, V, blue, indigo, and violet is absorbed. The green is reflected. Okay, now we have a red apple. Oh, I don't have red. I've got this red. Okay, we've got a red apple. Okay, so how does our girl see the red from the apple? The white light from the sun hits the apple, but it's just what the substance is made of and the molecules that are in it that absorb certain frequencies. Okay, so we have the red light only that is reflected off of the red light. The rest of it is absorbed. So we know not red, but orange, yellow, green, blue, indigo, and violet is absorbed. So the apple skin absorbs those colors, but it reflects the red, and we see it as red. Okay, lastly, we got yellow bananas. Okay. Okay, yellow bananas. So again, white light from the sun comes in, hits the bananas, but this time only the yellow will reflect into the eye, and the lady sees them as yellow. Now obviously you get the little black spots on the bananas, so what are the black spots going to do? They are going to absorb the light. So what colors here? We got red, orange, green, blue, indigo, and violet. The yellow is reflected. The rest of them are absorbed by the flesh, and that's when they can get warm. It just gets absorbed, that energy. Okay, so all of those colors are absorbed, but the yellow is reflected. Even though the white light has hit it, the yellow is reflected. Okay, what would the red apple look like in a green light? Oh gosh, so let's think about this. Only green is in the light. So a green light. Okay, we have an apple. Okay, and we know the apple is red. Okay, we know it is red. But sorry, I just had to pick something up. But if we're in a red environment, a green environment. Okay, let's take a look here. We know that green is absorbed when we see red. So this green light on a red apple is going to be absorbed. So if only green is there and it is being absorbed, that means all the light is absorbed. And what are we going to see? The apple is going, oh gosh, that's a terrible thing that I'm busy doing now, because you can't reflect black off. It's going to look black. Okay, in our minds, we think we're seeing it as red, but we don't actually. Okay, so it's going to look black because the green is absorbed. Don't do this line. The green is absorbed. Okay, so only green light, only red would reflect off of the red apple. So in a green light only, that green is going to be absorbed. That means no light is reflected off of it and it will look black. Okay, so it would look black. And I write it in green. So that was very confusing now. Okay, black. Why? Oh gosh, now we got to write the thing. Okay, green is absorbed by red things or red objects. Therefore, no light will be reflected. Okay, green is absorbed by red things. Therefore, no light will be reflected. Okay, I hope you understand. Right, last page that we're going to do. So reflection. So we're going to look at reflection now. So reflection of light is when light strikes a boundary surface of which it cannot pass through. So what does that mean? It means opaque. Okay, opaque. And moves back to the same optical medium. So that just means if it was in air, it's going to land up back in air. Okay, a medium is what the light travels through. Okay, what the light travels through. Okay, that is what a medium is. Okay, there is a law of reflection. So we're going to complete this diagram. Now, here is a light ray. Okay, one little ray of light that we're going to use here. So I'm going to continue this ray of light until it hits our boundary. Okay. Now, we're going to use and put an imaginary line. Okay, this is what happens, but this is what scientists use now to see this law. So where it hits this line, if we had to draw an imaginary line 90 degrees to the boundary surface, okay, this line is given a name. It is called the normal. I know, very cool. The normal. Okay, the normal. It's an imaginary line. Okay, and wherever a light ray hits, a normal, we can draw 90 degrees to the surface. Okay, there it is, 90 degrees. Okay, so we know that there's a light ray approaching the surface. There it is there. And the light that approaches the surface is called the incident ray. The incident ray. Okay, so it's approaching the surface, and now it's going to be reflected. Now, this is important. This incident ray, now girls, remember, you can pause this, you can rewind it, you can watch it a million times if you want to understand this, okay? So this is a certain angle, okay? I'm going to show you the angle, the reflected line now. Okay, so here it left, and I hope I've drawn this okay. So this is then called the reflected ray because it has bounced off of the surface. Okay, so the incident ray hits the surface, reflects. If we had to draw this imaginary line all the time, we would see something. We would see that that angle here is equal to that angle here. And we can label it an I and an R. Okay? And we say that I equals angle R. It is the angle of incidence is equal to the angle of reflection. Okay, and it will always make the angle with the normal. Now, I want you to remember it this way. Please don't do this in a test or something. I'm just showing you to help you remember. Okay, what are we making here? You're making a heart. So I want you to remember that your angle of incidence must make a heart with the angle of reflection with the look what I did. With the normal. Sorry, I smudged it. Don't do that. Okay. Right? So that we get a perfectly shaped heart. I don't want you to draw hearts for me, please. It's just to help you remember that the angle of incidence is equal to the angle of reflection, and that's when you're going to draw normal. So a light ray comes down, hits a boundary surface, leaves, and it will leave at the same angle. Okay, now I want you to practice this at home. I want you to stand in front of a mirror, and then I want you to walk left and right and keep seeing of what you are seeing. So, for example, if you have a mirror here, okay, and you are standing over here, that's the top of your head, okay, and there is, what can we draw that's easy? I'm just going to be boring. There's a block, okay, and over here is a triangle, right? So here's the mirror. Okay, mirror. Here's you. Okay, when you can see the block, okay, because the light shines off the block and into your eye, okay, and there you can see, if I draw the normal and those angles, you can see the heart. Okay, how do you need to move in order to see the triangle? You're going to have to move that way, because as you go, it will go like that. So the more you move this way, the more you're going to see that way. When you close your angle of incidence, you're going to see that. So try and have a look and see what you're going to do. Okay, so the law of reflection in words says the angle of incidence is equal to the angle of reflection. That is the law. Okay, the angle of incidence is equal to the angle of reflection. Okay, so we now see, oh, but you get different things. You get a smooth surface, you get a rough surface. How do we see something as rough and how do we see it as smooth? So let me think, what can I use? I've got a blanket. Okay, so let's see here. This is a rough surface. Okay, so it's not shiny. If I had to use, I'm going to use the surface of my calculator. You can see it shiny. Look, you can see things are being reflected off of it. Okay, I'm trying to show you. There's my light. There's my hand. I don't know if you can see what you can see. Okay, so this is a smooth surface and it reflects things quite neatly. Okay, there's the pen you can see. I don't know if you can see anything else. There's my face. Hi. Okay, and then this, you can't see anything. I can hold it anyway and nothing's going to reflect. This is a rough surface. Okay, in terms of light, I mean, it feels soft, but it's rough. It's not going to shine. Okay, so the smooth surface, these light rays come in, these incident rays, and the law of reflection says that they are going to leave where my angle of incidence is equal to my angle of reflection. Okay, sorry, that should be there. And so we see it as smooth and we can see this lovely shine. Here, if I had to take the blanket and look at it microscopically, we can see it's got all these little bumps in that. So let's just see here. If I had to draw a normal, now remember normal is 90 degrees to the surface. So imagine it's 90 degrees there. And over here, this is coming in. And here's my normal, 90 degrees. Okay, so if I come here, oh, it's like going to go right back on itself. Over here, my angle of reflection is going like that. See there's the little heart. If I land up going in the same as the normal, it's just going to go in its opposite direction. So I've got one light going there, one light going there, and they're all going to be scattered. They're all going to be all over the place. Okay, and so what happens, we see it as rough or not shiny, okay, due to the scattered light. All right, girls, I'm not going to do the eye with you yet. So I want you to please continue with classroom activity 5. And also, I'm sorry, I need to change the notes. I've changed them on my computer and I've put it on D6. I'd like you to do classroom activity 4 on page 181. This is important. Hint, hint. Okay, do this activity first, all right? The whole activity, it's not long. And then I want you to do classroom activity 5, page 184. So this is page 181. Okay, and it's all of it. And then page 184, number 1, 2, 3, and 6. Right. So 9B, you can continue with, 8B, you can continue with this now. 9A, please. I'm sorry, it's going to have to be for homework because I don't see you on Thursday due to Ascension Day. All right. Have a good day.